Okay, class. Good evening. I just want to pick back up from chapter 1, section 1. And we were talking about linear and rational equations. So, linear equation, to be exact, is nothing more than a relationship between two variables, whereby when you plot them, it's going to give you a straight line. So, for example, a linear equation looks something like this: y equals x, y equals x plus 2, y equals 2x plus 3. Okay? Now, in real life, you can use these linear equations to depict income over time, mileage rates, and of course, you can use it to predict profits. So we want to be able to solve a linear equation now that we understand what a linear equation is. Okay, we can take this simple example, 5 into x minus 6 minus 2x equals 3. Okay, and you want to be able to solve for x. Okay, solve for x. And in doing so, our first step is we want to be able to expand the expression. Okay? So, for instance, 5 into x minus 6 minus 2x equals 3. To expand the expression means to get rid of the parentheses, and that's 5x minus 30 minus 2x equals 3, of which you see right here. Okay? So in doing so, our next step will be now to group like terms, and when you do so, you now solve for x. Okay? And when you do that, our x happens to be 8. Okay? And group like terms is going to be, again, we have 5x minus 30 minus 2x. Okay, so this is x minus 1 here, I'm sorry. 2x equals 3 minus x minus 1. Okay, so we want to be able to group like terms together. And so now I'm going to keep the x on anything associated with x, I'm going to keep it on the left hand side. So it's going to be 5x minus 2x. And I have an x right here. Alright? And I want to bring it over to the left hand side of the equation. Right? So since it has a negative sign in front of it, whenever it crosses the equal sign, it becomes a positive. So now this becomes positive x. Right? Equals, then I have my 3, but then I have this negative 30. So again, this value doesn't have an x associated with it. So when I bring it to the other side of the equation on this side, that negative value now turns to a positive. So it makes it positive 30, and I just keep my negative 1 here. Okay? So this is going to be a setup, and this is what you see right here. Okay? Now, I want to take it a step further and just say, okay, 5x minus 2x is 3x. Then I have the x here. Then I have 3 plus 30 plus 3 gives me 33. Then minus the 1 right here. And then I can solve for x. And how do I do that? I want to get x all by itself. That's what it means, solve for x. So when I have 4x equals 32, this 4 is in the way. So if I divide this by 4 and divide this by 4, now I'm going to have x equals 8. Okay, which is what you see right here. Okay. Now, we're not finished yet. We want to be able to check to see if this value 8 really is true, and what can help us determine that, meaning that whatever your expression, this 5 into x minus 6 equals 3 minus x minus 1, whatever's on the left hand side must equal what's on the right hand side. Okay? So in doing so, we go back and plug in 8, which we have done. Okay? And when you do that, you find out that negative 6 equals negative 6. Okay? So what's on the left hand side equals on the right hand side. So you know that you're correct. Okay? Now, what I would like for us to do now, I want us to be able to solve a linear equation with an integer coefficient. Okay. So here's our expression right here. The first step is you want to expand the expression, and I showed you how to do that in the first example. So in doing so, we're going to have 6 minus 4x minus 16, and then equals negative 8 minus 6x minus 10. Okay. So if you have any trouble with plus times plus equals plus, negative times plus equals negative, plus times negative equals negative, negative times negative equals a positive. So if you may want to remember this when you're multiplying. Okay. So when we move forward, we now can establish our equation on the left hand side and one on the right hand side, and they have the equal sign between them. So now we get we get our x to equal to 0. Okay. So in this case, I just kind of want you to keep these kinds of expressions in mind. Okay. X equals 0. So if we go back and plug in x equals 0, we should get what's on the left hand side should equal what's on the right hand side. Okay. Objective 3, we want to be able to solve linear equations using fractions. Okay. And I know fractions has been somewhat of an impediment for quite some people, but I don't want you to be afraid of fractions. The only thing now is we want to be able to clear fractions, meaning we don't want any kind of denominator. This is a denominator, 3 is a denominator, 2 is a denominator. So we want to get rid of it. And how do we do that? We want to be able to find a number that both these expressions, both 3 and 2 can go in. And what number would that be? That would be 6, right? So if we multiply through by 6 on both sides, right, this is what we're going to get. Okay. And all I did here typically was just rearrange the expression. And what I did here was just find a common denominator, but you could just look at the denominator and tell that you have 3 and 2, and the common denominator is going to be 6. Okay? So now the question now becomes, we can now multiply through by 6. And what I mean by that is 1 minus x over 3 minus x plus 1 over 2 equals negative 2. If I multiply this whole expression by 6, right, this 3 goes into 6 2 times, so I'm left with 2 into 1 minus x. This 2 goes into 6 3 times, so I'm left with minus 3 into x minus 1. And then since I have this is denominator of 1, right, so that's just going to be 6 times negative 2, which is negative 12. Okay. And this is what you have right here. This part right here is the expanded part. Okay, I expand, I get rid of these parentheses, that's 2 minus 2x minus 3x plus 3. This is plus, sorry, this is plus. This has to be negative. That's negative 3. Let me just do that correctly. Negative 3x minus 3 equals negative 12. Okay? And then once I've expanded the expression, I'm just going to solve for x. And when I do, I'm going to get x equals 11 over 5. Okay? So now you can check this answer to see if it is so. Again, whatever's on the left-hand side of the equation has to equal what's on the right-hand side of the equation. Okay? Our next objective is we want to be able to recognize rational equations. And remember that a rational equation is nothing more than just a quotient of two integers, okay, or a fraction. Okay, so we actually solve the rational equation here, and this is our value here. Okay. Again, we want to be able to get rid of the denominator, so we have here x plus 2 in the denominator, x plus 2 in the denominator. So a quick way of trying to get rid of this is you can just multiply through by its denominator, and which is what I have right here. Okay, and this is what I have right here. And then when you do so, these cancel out. Okay, but don't remember that you have to multiply this value right here belongs to this value right here, belongs to this value right here, and also belongs to this value right here as well. Okay, so we do that as I've shown you here, um, and this is going to be x plus 2. Okay. Oh, okay, I'm sorry. I made a mistake here. This is not here because this is just a 3. So when you multiply through, you're going to get this value right here. Okay. And then when you want to expand now, you can just expand 2 minus x plus 3x plus 6 equals 4. Okay. Now, we want to be able to solve for x, and when we do so, again, we bring like terms together, and I like to put the terms of x on the left-hand side and the actual coefficients on the right-hand side, and then we get x equals negative 2. Okay. Now, if you notice that when you plug x back into the original equation, we will obtain a 0 in at least one of the denominators, right? So if you were to plug in x equals negative 2 back into this original equation here, you can, if x equals negative 2, this is going to be 0, this is going to be a 0, right? So we do that, we say, typically this is like a extraneous solution, okay? And typically what that means is this value here is going to be, has a 0, and this value also has a 0. 2 minus x, 2 minus x, with the x is being negative 2, that's going to be 4 divided by 0, which is not a solution. Okay? So it's called an extraneous solution. Okay? So keep that in mind, that you always want to check your values to know what kind of solution you have. Again, whenever you have a number over 0, that is typically called extraneous solution. Okay? Now, we have another example where we actually solve the rational equation. Okay? So we have this value has been given to us. We can take it the next step further, and then we can break up this value, this x squared minus x minus 20, into x plus 4 times x minus 5. Okay. Now we want to be able to clear the fractions. Okay. So our best bet really is to multiply by this expression here, because we can find x plus 4, and we also find x plus x minus 5 here as well. So we multiply through, you see that this denominator part cancels out with the x plus 4, and then the x minus 5 also cancels out, and we're left with this expression on the left hand side of the equation. On the right hand side of the equation, we're left with only 5. Okay. We begin to expand, taking x to the left hand side and the coefficients on the right hand side. You're going to get x equals 11 over 3. Okay. So now, if we were to plug 11 over 3 back into the original equation, okay, we'll obtain a solution where the left-hand side of the equation equals the right-hand side of the equation. Okay, so therefore, this equation is not extraneous equation, but is actually a solution. Okay. So whenever you have, again, whenever you don't have a solution, in this case, it's going to be extraneous solution. Um, while when you do have a solution, it's going to be actual, or if the left hand side equals the right hand side, is actually a solution as well. Okay. These are terms that I kind of want you to keep in mind. It's very important um, that you know how to determine if the equation has a solution or not. Okay. Thank you very much. Let's continue with example 8. Now we actually solve this particular um, polynomial. Okay, and I don't want you to fret, because whenever you see an expression like this, just break it up um, into its into factors. X plus 2 times x minus 1. And as you look, this looks familiar. This x plus 2, x minus 1, you can kind of see this also in other expressions. Okay. So now what we can do now is we can multiply the whole expression by this expression right here. Right? And when we do so, you're going to be left with this. Right? So you can continue to further the algebraic um, computation, whereby you're going to get 7x equals 5 minus 12. Okay. And you solve for x, you get x equals 1. Now, the interesting part about this is when you plug this back into the original equation, right? When you plug this back into the original equation, okay, you're not going to get a solution. Okay? Therefore, this rational equation is extraneous. It's an extraneous equation, meaning there is no solution. Okay? So you to take -1 and plug it back into here, you're going to get 12 over 1 squared, 1 squared plus 1 minus 2 minus 1 plus 3 over 1 minus 1 equals 1 minus 1 over 1 plus 2. So you have 12 over 0 minus 4 over 0 equals 0 over 3. Okay? So these, definitely, if you put that in your calculator, I'm interested to know what you'll get. You're not going to get a value. Okay? So what's on the left-hand side does not equal what's on the right-hand side. So therefore, there is no solution. Okay? I hope this helps. Kindly let me know if you have any questions, and I'd be willing to help you even further. Thank you very much.